Hey guys, just want to look at these notes and this homework assignment, kind of getting us ready for chapter six. So this is right at the beginning of chapter six. Just looking at exponents and the properties of exponents, like I said, just to get us ready for what's coming in chapter six. So there's really seven properties of exponents that we're going to look at. First of all, let's just go through these. Anything to the zero power is always one, except for zero itself. All right, so 3 to the zero power is 1. 5 to the zero power is 1. Negative 2 to the zero power is 1. Anything except for 0 itself to the zero power is 1. 0 to the zero power doesn't exist mathematically. All right. The next one, anything to a negative exponent is 1 over, or the reciprocal of that thing, to the positive exponent. So just for example here, 3 to the negative second power is 1 over 3 to the second power. All right, or 1/9. All right, so anything, negative exponents reciprocate things, or they flip things over. All right, when I am multiplying things with like bases, then I can simply add those exponents together. All right. So for example, let's see if I can come up with, let's come up with some examples here. So 4 squared times 4 to the third is really the same thing as 4 to the fifth. All right. And hopefully this makes sense if you think about it, because this is 4 times 4. And this is times 4 times 4 times 4. So what am I really doing? I'm really using 4 as a factor 5 times. Let me just come back here, give you an example here. So 2 to the 0 power is 1. Anything to the 0 power is 1. This is similar to what we did here, except when I'm dividing things with like bases, I can subtract the exponents. And again, I don't want to gloss over that. The bases have to be the same. So if this was 4 squared and this was 5 to the third, I can't do anything with those. All right, the bases have to be the same before I can use these properties of exponents. But in this case, if I have 5 to the sixth divided by 5 to the third, I can subtract those two exponents, and that's just 5 to the third. All right, and again, just to kind of by way of showing you here, 5 to the 6th would be 5 used as a factor 6 times, and then 5 to the third would be 5 used as a factor 3 times. And if we start looking at canceling out or looking at those ones, what I have left is 5 to the third power. This next one, if I am multiplying two things inside parentheses, and then that's raised to an exponent, I can distribute that exponent to both of those things, but that only works for multiplication. All right. So in other words, if I have 3 times 2 to the second power, that is 3 to the second power times 2 to the second power. All right. I can distribute that exponent through there. I can also do that for division. All right. So if I have 5 over 3 to the fourth power, that's the same thing as 5 to the fourth over 3 to the fourth. Again, that distributive property only works for multiplication and division. It does not work for addition and subtraction. And then finally, when I've got a power raised to a power, I can multiply those two exponents. So for example, 6 squared to the fifth power would be the same thing as 6 to the 10th power. All right. And again, hopefully, if we looked at that, this would be 6 squared times 6 squared times 6 squared 5 times. And then going by what we saw up here, I can add all those two together, twos together and get 6 to the 10th. So what you're going to be doing on your homework, we've got 3 just quick examples here, and then I'm going to turn you loose on your homework. But just want to write these. And I want to write these using only positive exponents. So if we look at this, this is 5a to the third times negative 3a to the fourth. First thing you have to understand is this is all just multiplication, and I'm going to write it that way. So this is 5 times a cubed times negative 3 times a to the negative fourth. All right. Let me just draw my line here so I don't get NB. All right. So this negative 4 has nothing to do with that 3. That exponent of 3 has nothing to do with that 5. I always say exponents are nearsighted. They only see what's right in front of them. All right. And now, since I see that this is all multiplication, I can use the commutative property, all right, and I can kind of multiply in whatever I want. So I can multiply these two together. I can multiply 5 by negative 3. And then I can multiply a to the third times a to the negative fourth. I'm just changing the order here because that's what the commutative property says, and the commutative property holds for multiplication. And now I can do what I can do. I can do 5 times negative 3. That's negative 15. And a to the third times a to the negative fourth, well, according to this property right here, if I'm multiplying things with like bases, which I have here, I can add the exponents. All right, so 3 plus negative 4, that's a to the negative first. So I get 15 times a to the negative first. Now here's the only thing. It says that once these written with only positive exponents, I can't have that negative exponent. Oh, wait a minute. Anything with a negative exponent is the reciprocal of that thing with a positive exponent. Now again, this negative 1 has nothing to do with the 15. That negative 1 only applies to the a. So this would be negative 15 times 1 over a to the first. Okay, didn't ignore that. That's just a mistake on my part. And that's an okay answer, okay, but I'd like to simplify that even more. It almost looks like I'm multiplying fractions. Let me make that into a fraction by putting that over 1. And then I can just do top times top. So it's negative 15. And bottom times bottom, 1 over a to the first is just a to the first, or I might just write that as a. All right, so I've simplified that as negative 15 over a. Okay. For b here, I've got this monomial to the second power, all right? Well, what this says is, again, I've got all multiplication in here, right? So that says I can distribute that exponent to everything in there. So I can do negative 4 squared. And then I can do x to the negative third squared. And then I can do y to the fifth squared, okay? What this property says is if you've got multiplication inside parentheses with an exponent outside, you can distribute that exponent to every factor of that multiplication problem. And now let's do what I can do. So negative 4 squared, that's negative 4 times negative 4, that's positive 16. Here, this is, where to go? Well, this is that property right there. If I've got a power raised to another power, I can multiply those exponents. So this is x to the negative 6th, and this is y to the 10th. Okay, there's a decent answer, but again, it wants only positive exponents. All right, well, what can I do with that negative exponent? Just like we did before, I can reciprocate that and write it with a positive exponent. Now again, this negative 6 has nothing to do with that 16. So this becomes 16 times 1 over x to the 6th times y to the 10th. An okay answer, but if I look at these as, hey, just a bunch of fractions by putting those over 1, so top times top times top, I get 16y to the 10th over bottom times bottom times bottom, x to the 6th. And so now I've simplified that expression. And then finally, this last one here, and again, I apologize, that should be Google Docs is capitalizing things for me when I don't want it to. All right, so this is 4ab to the 6th c cubed over a to the 5th bc cubed. Holy cow. All right, so what can I do here? Well, here, they've already got it written this way for me. I want to break it apart into this. All right, so I'm going to write it as 4 over 1 times a over a to the 5th times b to the 6th over b times c cubed over c cubed. So again, we're kind of working this thing backwards where they gave it to me like this, okay? But I want to explode it. I want to break it up into these parts. So now let's see. Well, 4 over 1, there's not much I can do with that. I'm going to leave that 4 over 1. And think about this, all right? There's a couple different ways you can do this, but here's kind of how I like to think about it. This is a, and this is a times a times a times a times a times a. A used as a factor 5 times. All right, let me write that out. A, 2, 3, 4, 5. Okay? And now if I look for ones or cancel out, that A will cancel one of those A's. Well, what am I left with? I'm left with 1 over a to the fourth. And if you look back at what we had originally, we had a over a to the fifth. Think of that a as canceling out one of those 5a's that I had on the bottom. Same thing's going to happen here. I've got b times b times b 6 times, and then I've got a b down there. That b is going to cancel out one of those, leaving b to the fifth. And I'm going to write it b to the fifth over 1. And here I've got c cubed over c cubed. Well, a couple of the ways you can think about that, but what I like to do is say, hey, wait a minute, that's just 1, right? That's just a fancy form of 1. So hey, that's just times 1 there. And now that I've got things kind of canceled out and simplified, I can go ahead and put it back together. Top times top times top, I get 4b to the fifth over bottom times bottom times bottom, a to the fourth. So that whole mess we had at the beginning can simplify to 4b to the fifth, a to the fourth. Okay, so I'm going to put this stuff out there, put that homework assignment out there. I'm gonna, this is just getting you ready for next the next chapter. If you can have this done for me by Friday, that'd be great. I know some of you have asked to have some of these assignments maybe a little bit ahead of time, so that's what I'm giving you an opportunity to do. So take a look at these. If you have questions, let me know. All right, and I will talk to you guys later. Take care.